Buddy, figured I'd better make a quick video here for HDX FH. And since Josh C here put this schematic up for this receiver, he's trying to get going. There's some easier and better ways really to troubleshoot this than pulling stuff apart. I agree that sometimes that's necessary, but these ones, these have some very good protection circuits, and a lot of them really easy to troubleshoot, provided you know what you're looking for. So, um, I used to be in this field. I wouldn't do this. This could cause you to loud out more blue smoke than you want, or permanently damage it. You don't want to do that. I advise against that. So, what are we going to look at here? We got a schematic. Hopefully, we've got a server's manual, so surely we should have a schematic. And first thing we want to do is we want to identify the microcontroller and the pins as DSP. Do they have one? It's DSP. Oh, here we go. Okay. We want to look for the analog to digital converter inputs on the microcontroller because those are typically used for voltage monitoring and protection. So see them right here actually. 89 and up. These are more than likely going to be your voltage detection stuff. So what the program that's running on this microcontroller is looking for is their voltage present typically on any speaker outputs. And if there is, we don't want to power up. So what it'll probably do, power up for a real quick, millisecond or something, a couple of milliseconds, power up, see if we got any voltages present. If so, power back down. Um, before we do any damage or hurt anybody, because that's the other thing. It's a safety feature. You don't want to have 50 volts or however many volts, this thing's powered with. It's probably typically 40 or 50 volts. You don't want to have that on speaker outputs. So if we look at these in this list of what these things do, we're going to see that we're going to have some things to look for. So protection in excess in current detection. We want to look at this one. This is not an A to D input. This is just a regular input. We want to look for a high here on 86. Protection DC detection. That's probably looking to see if there's DC on the output. We want to look at that one. And we want to look at thermal. We don't want to care about that right now. That's keyboard inputs. We don't care about that. And analog digital converters, ground reference. It's VREF. It's power supply, so on and so forth. PRV. This is an interesting one to look at as well, because this is to make sure the protection circuit has power to work. Because if it doesn't power, if the protection circuit's power supply has failed, then it can't detect faults, and therefore that in itself is a fault. So that's a backup for the backup. So we want to look for the schematic now of the amplifier and look for the transistors that typically, this is the old DSP. Okay, here we go. This looks like power amplifier to me. So we're going to look for some transistors and things that are going to toggle that. So we're going to be monitoring here. And that's what this is doing, clearly. This should not have any voltage present. If you have voltage present, this is usually a big resistor, big double resistor. This one's a 0.22. Some of them are 1 ohm, some are 0.22, some of them are 0.8. I've seen various, over the years, various implementations of this, basically the same thing across manufacturers. But we're looking for voltage here. If we have a voltage present here, then we're having bad news, because this thing obviously this transistor is switched off. So this is going to pull something down, like this bus, which is actually RCPRI, incidentally. There it is right there. This is going to probably run between all the amplifiers. We're going to pull this down, and when we pull that down, we're going to turn on this PNP transistor. We're going to turn this on, and it's going to pull PRI up. We're going to have a voltage applied to PRI. So that's going to go back to the micro. The micro is going to detect the voltage there, and it's going to say, no, something is wrong with the amplifier because we have a voltage present on the output. There's probably another one somewhere else that's going to back this up, incidentally, to make sure that we don't have any voltage on the output. So we're going to go, we'll follow this down, same deal on the right channel for the main. And I'm going to keep going down, same for the rear left, same deal. and the rear right. Here it is, same thing. These are all going to be tied together. And finally for the center, the same thing. All the channels that's going to be looking at voltage coming out of the amplifier. Why would you have voltage here? Something's gone very wrong in here. Or it could even be something's gone very wrong somewhere else. We could be getting it applied into the amplifier. Um, Typically, it's because something here has gone wrong. But that said, if we look, we'll probably find another one. So there's PRI. I didn't find PRV. But rest assured, it's probably here someplace. There's a PRD, and here's PRD right here. This one's going to be looking for voltage on the output. So this is another one. We're looking for voltage on the output. We're gonna, probably take this. We'll probably take this line low right here. To again, it's another protection circuit. It's another way of detecting it. And if you look here again, I just noticed this. We have steering diodes, and these are on the outputs. So again, once again, we're looking for voltage on the output. Um, there's your relay. And remember, if it detects voltage on the output, it's not going to close these relays. It just won't do it, because if you do that, you could be applying, full power supply, 47, 48, 50 volts typically, right out of the back of the unit, going through your speakers, and then boom, you got a fire, you got all kinds of nastiness. So again, steering diodes going on here, we got no power here. We got no voltage present. So what's going to happen if there's voltage present anywhere here? We're going to take this PRMET, which I didn't notice on the microcontroller, but I can believe that it goes there, and we're going to go high, and we're gonna shut down. There's multiple ways for this thing to determine if there is voltage present on the output, because that would be bad. So just gonna go and try to find PRMET in the list to see what it says PRMET is, or maybe was it EMT? PREMT. I'm sure it was EMT. Power limiter detection. Yeah, we don't want to. It doesn't want to have power on the output. That's really all all of this stuff is about. Um, we don't want to have any. There's obviously two variations of this. Um, Same thing. So we've got this one, and they're basically the same circuit from what I can see. And they're really. I mean, there's only so many ways that you can uh, design such protection circuits. So I mean, they this is typical of receiver protections to have something like this. Looking for power here, we're looking for power here, we're looking for power 3 and 4 different ways. And if we got power on the outputs, we simply will power down. Some units say protect on the display, just protect. Some units flash a light. Some units, there's all kinds of different ways to display on the panel that there's a protection. Some of them just do what his does, a click, and they don't do anything. So my suggestion is to check every one of these transistors. First, let's cut to the chase, and let's check here. And this is assuming the power supply voltages have been checked. If all power supplies are present, these positive and negative 47s and the plus and minus 5s and 12s, if these are all present, then we need to go here. See if this line pulses. Peak hold on a voltometer if it has it. Single shot on a oscilloscope, whatever. Make sure this line doesn't pulse up, because if it does, then when it powers the amp, we're getting voltage on the output, and we're going to go right into protect. Now, if you get it here, that's when you start looking here on each one of these circuits. So Q130 base, you're going to look for this to pulse up. If it pulses up, then this is your amp. That's bad. Now, if all of them pulse up, then you need to double check these power supply voltages, because it's unlikely that all of them are bad. I've seen people do it. I've seen it happen. but it's not likely. But so you're going to look for the ones of these that pulse up. If you're not getting any pulse up here, make sure you look here and see if you're getting a pulse up. Remember, we could be getting it through, on these diodes right here. So look for a pulse up here, on these diodes. See if you don't have anything, any output spikes on them. Because remember, it only takes just a quick jolt for the micro to detect that, because it's probably on interrupt, and so it's going to take priority because it's a safety feature. So there's probably an interrupt tied to that internally in code, and it's just going to say, boop, nope, I'm not going to do anything. I'm just going to shut down. So it triggers a protect routine and powers down immediately. So anyway, and this is pretty much the case with almost all receivers. A similar design to this Yamaha. Sony's look very similar. Yeah, JVCs. I mean, doesn't matter. They all have very similar sorts of things going on. This one's actually fairly well documented, and I like this. So it should be, with this information, there should be no problem repairing it. There is one last potential issue, particularly when not finding any shorted outputs or any power supply problems. We go back to that microcontroller. Um, I have seen in my days when I used to do this work, I have seen these A to D inputs fail on a microcontroller where they don't work anymore, and the unit is, uh, you know, uh, it thinks there's something going on all the time, and it's actually a failure in the silicon in the microcontroller. I've seen it happen. I'm not saying that's the case here, but it's possible. It's a lot less remote uh, than just having a bad amplifier, but it's possible. And if that's the case, um, this is going to be, depending on how old it is, this microcontroller could be unobtainium, you know. But I have, in days past or years past, I've changed the microcontroller and a receiver because it was bad. I mean, in one case, I remember doodling around with it, and I remember throwing a resistor on one of the lines on it and pulling it down, and I was able to pull it down enough so that it worked, but defeating the protection circuit. But there wasn't anything wrong with the circuit. It was just the microcontroller internally had failed. Anyway, so I hope that this is helpful in some way in diagnosing and troubleshooting uh, a receiver like this that has protection circuits like this. Like I said, you've got more than one. In this case, you've got like four of them conspiring against you. A backup for a backup for a backup. So anyway, I hope that was helpful to anybody out there, particularly Larry here, and see if he can get this thing going. So anyways, guys, thanks for watching. Catch you next time.